A lot of the different networking components really look similar. Well, how do we differentiate them? Find out more next.
You're watching IT Pro TV.
Over on the bench right now, I see a bunch of rectangles and some things that actually look like antennas. But Wes, what we also have to do, of course, is be able to kind of compare and contrast them, right?
That's right. You know, as in your certification endeavors or in support endeavors, when it comes to the networking technologies, it's important to be able to identify and explain the purpose of these devices so that you can have that conversation should you be sitting on the IT staff. So that's what we're going to look at today, a variety of the most common networking devices and what is their purpose? You know, what are they actually doing for us within networks today?
All right, I see a mountain of hardware over there. Let's go ahead and get started.
All right, everyone, join us at the bench here, and Ronnie is right. Don't worry, Ronnie's credit isn't bad. I didn't buy all this equipment here, but we have a variety of networking equipment. And one of the first things that we're going to do, you know, I put these together in a way that I believe will help you to see how are they chained together, right? Because when we talk about networking devices, networking components, we have a variety of them. And the first component that is typically in that chain, if we take a close-up view, is going to be one of these. And that is something known as our network interface card. Now, if we stay on that close-up view, I want you to understand that that's a dedicated adapter that you could replace in a machine. But I also want you to take a look at that back I/O panel over here too. There's also embedded network adapters or network interface cards, NICs as they're called. And this is the first point of that end-to-end communication. My computer generates via the operating system, and the protocols built into the operating system. We call that the networking stack, and it generates data to send out over the network. Well, it actually starts right here. It starts the network adapter locally, and then that's when we put it out on the electrical medium, and it's got to go to other devices within our networks.
All right, now Wes, from that NIC, when we start talking about networking, right, we're going to have to put it into some type of connectivity device. One of the earliest ones was a hub, right?
It was, you know, and in the earlier days we were using hubs because they provided plug-and-play capabilities, and it was an easy way to add multiple devices to your networks. Well, I don't actually have a hub today, and the reason is they're more of a legacy device. And what I mean by that is when you would plug into one of the ports on the hub. All right, so for instance, if we take an overhead view, this isn't a hub, but it would look a lot like this. It might be smaller in size, but when I plug into the hub from the network adapter, when the communication comes out of the network adapter and went into the hub, it would just repeat the signal across all the other ports. So the more devices you connected into one of the hubs, the more congestion you would get within this type of networking device, because every time a signal goes in, broadcast out all other ports. Another signal goes into another port, broadcast out all other ports. So it was okay for very, very, very small environments. I mean, even small businesses wouldn't be able to use it because of the contention that it brought. So the hubs are more of a legacy thing, but we put them in here just for the sake of completeness because you might still see them used for other purposes today, but we typically do not use them because of the performance degradation that we get when we use them.
Yeah, it's interesting about the hubs because they are all hardware. There's nothing that actually tells the traffic that comes in to go out one port or another. But we do have switches that have really kind of replaced hubs.
They really have, because at this point now, it's not just plug and play with no configuration. Well, you know, maybe it is, maybe it isn't. But the big thing is now we can use things like MAC addresses. We can start to use addressing protocols, and the connectivity device can start to make decisions on where to send the traffic. And that's where we get various switches. Now, there are a couple of different types of switches that I want you to be aware of. If we take a close-up view here, this is what is known as an unmanaged switch. Now, I will tell you, I said plug and play for the hub, but technically this is kind of like plug and play too, because it's unmanaged, and when I power this on and I plug a device in, it has the logic built into the circuitry that says, oh, okay, if I send in information in this port, I can see that it's supposed to go to the computer that is connected to this port, and now all these other ports don't have to have that contention like we did in the earlier days of the hub. So this is technically a plug-and-play type technology, but remember that it does have logic, and the switches can actually make decisions on where to send the information, and it helps to alleviate some of the contention that we had using the earlier hubs. Now, I do want you to understand that these type of managed switches, they are limited in their capabilities. We typically use something like this big switch right here in enterprise networks. This is a Cisco-based switch, and this is what's known as a managed switch. Now, I would be remiss if I did not bring Ronnie into this conversation. Ronnie, would you mind telling us a little bit about this managed switch? Because I know this is your world. This is where you live.
Yeah, when we start talking about the differences between managed and unmanaged switches, a managed switch allows us to go in and configure, if we choose to, each and every individual port to do something a little bit different as we want to. Most of the switches today even allow us to logically divide that switch up into smaller switches that we also call VLANs. That's going to be very important for businesses that can afford to buy one switch but really need, let's say, 3 physical switches. So that's not the only thing that they can do, and there's plenty of different functions with them today, and they can even take on, of course, even routing capabilities today as well. So Wes, speaking of that idea, right, that we actually have switches in that way, they can actually go beyond just providing paths for data to actually go across. They can even provide power too, right?
They sure can, and that's through a technology that we call Power over Ethernet. All right, Power over Ethernet is a technology that, like Ronnie said, that you can actually inject power into the Ethernet cable, and this is very good for devices that do not have access to an AC outlet to power them via an AC adapter. So we can bring the power to things like IP cams, voice over IP phones. This little access point that I've got right here, if we take a close-up look, you can actually see the little PoE right there in the middle. Now I want you full transparency on this one. This is what's known as passive PoE, and it's saying that, hey, if you've got PoE on your network, we can pass it through this port and it won't fry the port. There are some PoE, Power over Ethernet standards, that I want you to be aware of. I want you to know as well as some of the components, right? So if your switch doesn't support the PoE standard, you can get an injector and it will inject the power into the switch. The switch could have it built into it. Some of the standards that I want you to be aware of are the first PoE, that would provide what is 15.4 watts of power. The PoE Plus, the first rendition of it, that would produce 30 watts of power, and I want you to be aware of that. But then they got in and they went to PoE++, and there was what's known as Type 3, and that was a 60-watt capability, right, increasing the amount of power that could be over that sent across those lines. And then finally, there was the Type 4 PoE++, and that would give you up to 100 watts of power out of those ports. If you're in a certification endeavor, I would know some of those statistics. If you're supporting this from a technician standpoint, it is important to match the statistics, or the standards, I should say, up with whatever the specifications of the technology that you're implementing.
All right, Wes, I see that thing with the antennas over there. Can you help us out with that? It looks almost like an access point, but it also looks like a TV antenna.
It certainly does. This is what's known as a wireless access point. An access point essentially is a wired device that gives you your wireless devices access to your wired network. All right, our wired network is typically through our switches, right, and that allows us to communicate across our local networks, but we need to add wireless devices, and this wireless access point would do that. I can bring this up on our networks, and then all of our mobile devices, our tablets, if you will, other wireless devices can actually connect through this access point back to the wired network.
Yeah, and a lot of times, especially for the home use, right, those actually are multi-function devices that have more than just the access point to them. But speaking of that, now that we've talked about hubs and switches, we need to talk about routers, right?
Most definitely. So what we're doing is we're getting to the edge of our networks. Local area network communications are handled by switches, but one of the things a switch is limited to is it's only aware of the devices that are directly connected to the ports that we essentially see across the switch interface. Now, if I want to get communications to other remote networks, well, that's where the router is going to come into play. Now the router here is another one of these big boxes that we see down here, or could be built into a multifunctioning device like Ronnie was saying, where the routing functionality is built in. The switch would connect into the router, and the router connects to your ISP and allows you to send communications off of your local area network. So you can see that in the chain that we're building here, we're working closer and closer to the edge of our network. So the routers work on things like IP addresses and allow us to communicate across networks that we are no longer, or we're not directly connected to. And that's one of the beauty of routers, is they allow us to communicate across the internet today.
Yeah, we can also see not only are there routers though, but you might also, of course, hear about the idea of firewalls too, right?
Yes, and Ronnie, that would be the next one in our chain. So this here is a router, or this here is a firewall box. And what's interesting is it doesn't really look like much. But if we look at it closely and we look at the ports here, we have a couple of ports. We've got a port for our LAN side interface, and we've got a port for our WAN interface as well. And this would sit outside of your router, in between your ISP's connectivity device. And what it does is the physical network or hardware-based firewall screens all of the traffic coming in and out of your network and comparing it against a set of rules, and it either allows or denies the traffic, and it's a way that we try to increase the security of our networks by implementing one of these network-based firewalls.
Yeah, when it comes down to that, right when we start talking about the edge, most of the time people are confused by that. What do we mean by the edge?
Sure, the edge. Okay, so when we talk about the edge network, the edge of your network, what I'm talking about is, think of it as abstractly, logically, right? It doesn't necessarily mean physically it's sitting in the building on the edge, teetering off the side to some unknown location. When we talk about it, we talk about logically. We have our local area networks that are within our buildings, but then we need to communicate out of our building and go out over to the internet. Well, that edge point between our internal networks and the networks that are typically like ISPs, the router sits right there, acting like a gateway to remote networks. So it is important that we are aware of that.
Yeah, so with that idea of that modem that we're talking about, right? Where else do we go from there?
Well, sure. So this is one of the last stops, if you will, in the chain from the network adapter out to the internet. And what I have here is a modem. If we could take an overhead view of this, you can see this is an AT&T modem, and it's got a series of ports. And what I like about this, remember Ronnie said the multifunctioning device? Well, this is actually an example of a multifunctioning device because it's actually got a switch built right into it. But what I'd like to show you is a closer look of the ports that are on the back. These are important, right? Because what we see here is we've got our LAN communication. No, these are our phone lines here. This is our LAN communication. And this is our cable side, our cable line, right? So this is a cable modem. It's also a dial-up modem. But even cooler, it's also a DSL modem, if we could see right there, digital subscriber line, as well as something known as an optical network terminal. All right, an ONT. So what is an ONT? Well, an ONT essentially is a fiber optic connection, a residential fiber optic connection to a fiber optic network provider, something like Fios, if you will. So this is what's made us really from the network adapter all the way out to the ISP's device that allows us to communicate off of our networks. One of the last couple of things that I'd like to mention, Ronnie, here that I haven't mentioned yet is they talk about networking hardware. Remember, we're not just talking about networking devices, we're also talking about the physical hardware. And one of the things they mention is a patch panel. And if we take an overhead view, a patch panel really is nothing more than a series of ports. All right, we take that closer look right there, and what you'll see on the back of it is this is a way that we can hardwire our twisted pair cabling in our server closet when you have something like structured cabling. And then we can connect a pair of drops just by moving the patch cables between ports. So it's another part of your networking hardware that I want you to be aware of and be able to identify. These are some important hardware concepts that you should be able to identify.
Yeah, with the patch panel, it actually most people that haven't seen it before or understand, what we're actually trying to do is bring all of those different wires that may be spread across your entire building and have one location that we can plug our networking equipment into, right? The switch that you see right there in front of Wes is only in one location, but it has to spread throughout the entire building. So instead of actually running an individual wire to the other end of the building, what we do is run everything to that patch panel, and then we can run shorter, what we call, of course, patch cables directly into the switch to allow the switching to happen. So that's actually important as well as we try and logically figure all this stuff out too. Now, Wes, There is one more item that you do have on our list here. This one is probably the more complex of the ones that we're talking about.
It really is. That's something known as SDN, or software-defined networking, right? These are physical devices that require configuration on an individual device level. Wouldn't it be nice that we could throw a logical, if you will, blanket over these? Don't do that, you'll overheat them. But if we could throw a blanket over and abstract all this hardware, and we could use software and programming language, and we could programmatically control all of these devices, and control them in a way that allows us to build the network through software, again using code in order to configure it. It is a very important technology that we find in endeavors like the cloud today. These are some of the networking pieces of hardware that I want you to be able to identify, so that if you're in a certification exam, you're going to be doing good. And if you're in a support role, you're going to be doing well as well.
Thank you for watching IT Pro TV.